Welcome to Troubleshooting Memory Usage and Performance in Revit Products. My name is Harlan Brum. I'm the Global Technical Lead for Revit Architecture in Autodesk Product Support. In this class, we'll explain the symptoms of a memory and performance problem, the difference between these two types of problems, warning signs you may encounter, and the error messages you may receive when experiencing these two types of problems. We'll talk about the methods and tactics you can use to resolve these issues, and the ways to test memory usage and performance problems. Performance and memory problems can be identified based on two factors. The first being the actual problem that occurred, and the second, the warning sign that led up to that issue. Let's talk about some common problems and warning signs regarding memory usage and performance. Common problems can include things like slow completing of tasks, slower than typical work on a large project, long click and release time. Click and release time refers to selecting an object within the Revit user interface, and it takes a long time for Revit to accept that click. Slower pan and zoom speeds when looking at a large file or large views. Finally, tasks or tools not completing at all, like clicking on the print icon and the document doesn't print, or exporting to DWG and no DWG file is created. There are a number of warning signs before these types of problems occur to look out for in your projects that can contribute to these types of issues. Large amounts of unresolved warnings within the project can cause the files to slow down. If your computer is slow to launch, it could mean that you have a number of applications running in the background, and those applications can eat up system resources, actually causing Revit to slow down. Finally, there could be long pauses when you're modifying geometry or modifying properties. These items indicate that memory may be being used up on the machine, which could cause the system to slow. Understanding the difference in a performance or memory problem can be key to troubleshooting the issue. The definition of a performance problem is a significantly slower than normal task completion. The customer may say, X, Y, and Z needs to be faster within the product. A memory problem, on the other hand, typically means that the task cannot be completed at all, or the product may be crashing. The customer may say, I cannot do X, Y, and Z. Defining if it's a performance problem or a memory problem can lead you down to the right path to troubleshoot. Often, performance problems are caused by not meeting the minimum system requirements that are laid out on Autodesk.com or on the products box. There are a few areas that can contribute to performance problems that you need to pay special attention to. The first would be graphics cards. Make sure that you have the latest graphics card driver for your hardware. This is an important step to make sure that your hardware is optimized for running the software. Make sure you meet the minimum system requirements as well. For 2011, make sure that your graphics card is on the certified graphics hardware list and that you can use hardware acceleration within the product. This can have a significant contribution to performance in Revit 2011 products. Next, make sure your processor meets the minimum system requirements. Also, check on the configuration of your network and machine. Make sure that your users have the proper permissions in order to access all network locations. Finally, performance can also be impacted by how complex the model is. Be careful about creating too many relationship constraints within the model. Revit needs to rationalize all the constraints that are within a model at any given time. When making changes to your model, if performance suffers, it's possible that there are too many relationship constraints going on that need to be fixed in order for Revit to process and speed through the change. Memory usage, on the other hand, often has to do with the complexity of the task you're trying to complete. Things like printing, rendering, exporting to DWG or another file format, or upgrading the file are memory-intensive tasks. These are often the areas where you will encounter a memory-related problem. Also, it's important to look at the model's complexity when dealing with memory issues. A contributing factor for memory issues can be over-modeling, providing too much detail in the three-dimensional space instead of using detail components and drafting to fill out the details of your project. Also, check to make sure your file is not too big for your hardware. Files including all links are expanded up to 20 times when they are loaded into memory. This means making sure that your model and your machine are in sync and that your machine has enough memory in order to open the complete file and all links within memory, taking the size of the file, multiplying it by 20 to determine how much memory you need on that machine in order to utilize that file. It's important to understand how to measure performance and memory usage problems. For performance problems, a good tool is a great old stopwatch. A stopwatch can be used to compare the performance of a project and a default template. The default template being a blank environment with no families and no project loaded, versus the project environment, so you can see if the issue has to do with the model or Revit itself. Another great tool is AU Bench, which is available from the Augie forums, which can be used to measure performance. The AU Bench is a journal file that creates a sample project and measures the results. Journal files are a great place to go and look for memory-related information. Journal files periodically record physical memory and virtual memory information within the text of the file. You can look for the words RAM statistics to understand more about what is happening on the machine at a certain time. The task monitor can also come in handy. Using the Windows Task Manager, you can monitor the process of the Revit.exe, the percent of the CPU that's being processed, the amount of memory that's being used by the application, and the total CPU usage, understanding how much Revit is using at any one time along with other products that may be running on the same machine. Finally, the last tool and resource that may come in handy is the Work Sharing Monitor. The Work Sharing Monitor includes a task manager and memory allocation monitor, so you can check to make sure Revit has enough available memory in order to complete the tasks you need. You can use the same tools and resources for understanding memory and performance issues to actually diagnose what's happening. Using journal files and the task manager, you can understand exactly where a problem is occurring in order to resolve that issue. RAM statistics and virtual memory within the journal is the most helpful. Journals also display information regarding whether or not the user's 3 GB switch is enabled and specifics about the machine's hardware and drivers. The task manager is also an important tool for diagnosing memory and performance related issues. Now, let's discuss some ways you can improve performance and memory usage. There are a number of things you can actually do within the model itself to help these two areas. The first is to avoid over-modeling. Don't use 3D geometry where detailing will work just fine. If you can get away with detailing with drafting lines and text notes, Don't add that additional geometry to the 3D project. Overmodeling is a very large contributor to performance issues and having too large of a file to work on. Also, avoid over-constraining when possible. This means try not to constrain things outside of the family editor. Additional constraints outside of the family editor means Revit needs to reconcile these changes each time a piece of geometry is moved. Revit needs to make sure all the constraints can be satisfied. This adds to processing time the more constraints you add within the project environment. Revit by default already adds a number of constraints. Adding more constraints to this can cause additional problems. Avoid adding any unnecessary links or families. Using the Purged Unused tool can help keep the files light and improve memory usage. It's also maybe a good idea to break up the model into smaller pieces that are more manageable and easier to open. It's important to understand that each file that's opened by Revit consumes 20 times the amount of memory of the size of the file. Revit expands the files into memory, so it's important to be able to break up your models into smaller pieces so that they don't get too big in order for your hardware to open them. Also, make sure you run audits and purges on the file regularly. This keeps the file small and can help keep away any corruption. From a system perspective, there's a few things that you can do to help Revit run a little bit more smoothly. Shut down and restart Revit at least once a day, perhaps over lunch. This is a good opportunity to shut down the application and reopen it when you come back. This will refresh the memory usage on the machine, allowing Revit more access when you come back. It's also a good idea to shut down and restart the system at the end of the day to release any system resources. Having your computer running for weeks on end can often cause memory issues to occur. Also, shut down any unnecessary applications while running Revit. This is especially true when you're about to run a memory-intensive task, as outlined previously, like rendering, upgrading, printing, or exporting. With memory usage and performance, it's important to keep in mind a couple of key things. First, the 3 gig switch will allow you to access bigger files. It will not improve your performance. It will not make things faster. It's also important to know about the 3 gig switch for Revit 2011 products. In Revit 2011 products, hardware acceleration will be disabled by default. This will cause a reduction in performance in 2011 products. It can be re-enabled via the options menu. However, this could result in a crash. Certain graphics cards rely on the space needed with the 3 gigabyte switch enabled. It can use up that space and cause problems, causing Revit to actually crash. It's important to know 64-bit is for larger models, just like the 3 gigabyte switch. It will not necessarily result in faster speed. Today, we talked about the symptoms of a memory and performance problem, the difference between these two types of problems, how to test and verify memory usage and performance issues, and finally, how to improve performance and memory usage within Revit products. Thanks for joining me today. I hope you learned a lot.